has been quite exciting in the last years to establish this focus area. And yeah, it keeps on being very exciting because there have been also some great announcements recently. You might have seen that the Nobel Prize for Physics has been awarded in the field of machine learning and AI, in particular for developments in neural networks that have enabled basically all these developments that we have seen now in the recent years. And yeah, Hopfield and Hinton were certainly very important pioneers in this regard. And especially Hinton was then also referred to as the godfather of AI, basically. And I think it's remarkable to see that this is the Nobel Prize for Physics. So it's not really computer science or so, but it's really a demonstration to see that these developments, these algorithms are of great importance also in many other fields like physics. And it has, for example, been applied to cosmological simulations and detection of exoplanets and detection of also physical relationships. So I think this shows really the great opportunities that are enabled by algorithms like neural networks. Yeah, before discussing the focus area in detail, I would also like to report from a recent conference that I visited in Zurich. It was actually a conference focused on AI called AI plus X, a summit where a lot of scientists in the field of AI and also industry leaders and entrepreneurs came together and exchanged on recent and hot topics in the field of AI. And it was quite interesting to see that there are a lot of keynotes that have been quite inspirational, and certainly many people are motivated, stating, for example, that AI is the fourth industrial revolution, like after mechanization, then electrification and digitization. Now it's AI, maybe the next big step. And well, for that, it's also really important that everybody here can use nowadays AI, because there has been like the ChatGPT release in 2022, which has been also referred to there at this conference as AI's iPhone moment. That means really making a really big jump to establishing AI really also widely in society. And so certainly there's a lot of hype, but I'm not surprised that this is really a conference dedicated on AI. And certainly there have also been quite a lot of good discussions on limitations and concerns, for example, related to ethics and problems or challenges in the future. Well, is it really just a hype that is very short and it might also fade away, or will it also stay here for a longer term? And I think it's quite interesting to see some statistics about the investments going on into the field of AI. And you can see that 2021 there was a huge peak, and since then actually tapered off a little bit. And at the same time, actually, the investments go now rather to a specific field of AI, which is called the generative AI. And this includes the large language models like GPTs or other models like Llama, Gemini, and so on. And also, of course, then not only for language, but also for image generation and video generation. So this seems to be the future direction where investments are going currently, although it remains to be seen how the overall level of investments in AI will develop. So it's unclear, I think, how it will develop in the future, but I think what is quite striking about this plot is if you actually look at the numbers. So we're talking here about billions of US dollars. And so over the last few years, I think in total there have been almost $1 trillion of US dollars being invested into the fields of AI, and all the major tech companies like Microsoft, Facebook, and or Meta, basically, and Google really heavily invest in this field still today. And so I think given the great amount of investment that already has been made, I think this will still be definitely a thing in the next few years in the future, and pretty much it will creep into many different applications, like everything related to recommendations, translations, services like chatbots and so on. But yeah, this is a bit more about the maybe industry, but more interesting is actually how AI can be used for science. And actually at this conference, there was also a workshop for AI for science, which was quite interesting because it also brought together not only scientists, but also people from the industry that work on science. So basically R&D at big companies. And I just want to highlight some key takeaways from this workshop. Basically, it became evident that these big companies like Google, NVIDIA, and so on, they really not only invest in some commercial products, but also really in science. And that includes, for example, developments for AI, for science, for medicine and health, like there has been this very successful AlphaFold model now in the third version already just released this year, which can predict protein structures and then also help to develop new drugs. And then, AI for chemistry, material science, and also for Earth system modeling, in particular for climate predictions and weather forecasts. And one example is, for example, Google's GraphCast model, which has been released actually last year and which has been very successful and has been beating actually the previously best standard numerical weather prediction models like provided by ECMWF. And is now being actually integrated into the weather forecasts of some national agencies. Now, actually, one important takeaway for me was that the magic ingredient, let's say, for most of these very successful models that have been released is actually the amount and the quality of the data that has been used to successfully train these models. So nowadays, I would say model choices, so the specific algorithms are already quite mature, typically based on deep neural network or specifically transformers and so on, or depending on the application, for example, also graph neural networks. But I think the overall impact is not so large of these choices. And also the computation is not longer an issue for these big companies because they have huge data centers. And it also costs a lot of money, of course, but that's not an issue for these big companies. But what's essential is really the amount of data that goes into that. And especially for such models like presented here, the amount of data is quite impressive, certainly. And that allows you to train models that are using billions of parameters, actually. Now, actually, that is, I think, a good link to the field of geodesy, because I think in geodesy, we have a great potential of using a lot of this data that we collect. And in particular, there has been a great increase in the amount of geodetic data recently. If you're thinking about how many permanent GNSS stations there are around here, this is a map with 18,000 stations that really deliver not only a lot of data, so just continuously observing, but also very high quality data, allowing positioning at the millimeter level. Also, INSAR, of course, provides a lot of data, altimetry, and the gravity field missions. And we can also use, of course, and benefit from many of the other models that are out there, like weather models, climate models, and fuse them with geodetic observations to really produce very large models also for geodesy. And we also have a lot of problems to be addressed that are very suitable for machine learning, like data fusion, combination of data, spatial temporal modeling, time series prediction, anomaly detection, and so on. So this has really motivated this generation of the GGOS focus area, which is chaired by me together with Maria Kasalini from Greece. It has been originally approved in 2023. And it's now, I think, nicely established within the other focus areas and other components of GGOS. Now, GGOS focus area, I think, is the best choice for this because we are really focusing on applications, so on the geodetic data and the products and how these can be used for machine learning applications and then also further improve these products for geodetic applications. Now, the main objectives are to develop machine learning models that can improve geodetic products. And then also very important, I think, is to evaluate them very thoroughly and study, for example, the limitations of machine learning algorithms, errors, and also uncertainties to give more trust into the machine learning algorithms. And yeah, geodetic products could be improved in various ways. For example, higher accuracy, higher resolution, or overcoming some latencies and enabling the application for real-time problems. Now, the focus area is organized in 4 joint study groups, which have been now quite stable. AI for GNSS remote sensing, then AI for gravity field and mass change. So here we have luckily also found a new chair, since the previous chairs and vice chair had to step down because they changed the field or went into industry. Then we have AI for Earth orientation parameter prediction and AI for geodetic deformation monitoring, which started a bit later than the other 3 joint study groups. Now, detailed descriptions of each of these components can be found on the website, so I will not go into detail here. Just an update on the development of the members of these joint study groups. There's been still a strong increase, and overall there are now 90 members involved, distributed over the various joint study groups from 20 different countries and 50 different institutions. Now, this presentation should also highlight definitely also some recent developments within these joint study groups. I will just show some selected highlights because the complete list has been submitted as a report to the like an annual report for GGOS, can be then read in more detail. So one of the I think ongoing activities is certainly to help with popularizing and encouraging research in the field of AI for geodesy through, for example, special issues in journals, but also conference organization and sharing and convening sessions. For example, we had at EGU 2024, so this year, quite a successful session with an oral block and a lot of submitted abstracts, and it has been also now submitted again for next EGU, really with all the with most of the chairs of the joint study groups involved. Also for the first time at AGU, submitted a session on machine learning or AI ML in geodesy. And also as Michael mentioned last week, or last days, we had the GGOS topical meeting on the atmosphere, which also had a lot of contributions, and a session on artificial intelligence related to the atmosphere. There will be also a workshop on GNSS reflectometry, which has also always a great implication in terms of using machine learning in this regard. And also very exciting, I think, is that for the IAG Scientific Assembly 2025, we will have a symposium on data science and machine learning in geodesy, which is then not just one session, but we are currently planning for 3 sessions. So 2 sessions related to the focus area here, and then also 1 session related to theory and mathematical foundations in machine learning for geodesy. Now, one very exciting initiative is that together with the chairs and members of the joint study groups, at least those from Europe, we have worked on a proposal to like the program Cost Action, which is really very nicely aligned to what the focus area is doing. So basically, right now it's of course without any funding, but if we could get this proposal, then we would be able to organize meetings, conferences, workshops, for example, hackathons, mobility between the different members of the groups. And this is quite would be really enabling, I think, further collaborations. So we tried already last year. It was, of course, quite competitive, and we learned a lot about the feedback that we received from the reviewers, and that has encouraged us to also try again this year, and we are currently preparing a resubmission of this cost action proposal. And it is really necessary to establish a wide network with many different countries involved, researchers from many different also career stages and genders. So we also really trying to improve this balance. And yeah, I think we have been very successful so far here with over 50% females and also 60% from countries that are in this cost inclusiveness target countries list. Now, another activity is that some members of the focus area are writing currently a review paper on uncertainties in deep learning. This is one of the main objectives of the focus area. And yeah, it has been established or encouraged or during a workshop on essential climate variables for climatology and focusing on the uncertainties. And this particular paper focuses on GRACE and GRACE follow-on data. So basically how machine learning and GRACE data can be combined to assess the uncertainties. I think also one very successful example is from one of the joint study groups, the one on AI for Earth orientation parameter prediction led by Sadek, who is also here, is that they have organized webinars which have been very well attended, related to some of the most important research that has been going on, for example, on using recurrent neural networks for UP prediction, and then later using physics-informed machine learning for explaining UP variations. And if you're interested, you can still watch these on YouTube on the GGOS channel. Now, also a main objective of this focus area is to encourage the research and exchange the developments in the different fields from the different members. So I would just like to highlight a few very selected research highlights that happened during the last year. For example, from our new chair of the joint study group in gravity field and mass changes, Wu-Peng Li, studied forecasting of GRACE and GRACE follow-on solutions using machine learning up to 1 year ahead, not only on individual time series, but also globally, which reveals quite a good distribution and where, for example, flooding events are more likely to happen or droughts. Another example is to use machine learning for downscaling, so improving the spatial resolution of GRACE terrestrial water storage models, but combining, so fusing the GRACE data with hydrological models. And this has been also in a perspective mentioned that was published also in Nature Water, where they refer to this study as a foundation model. At least it's not as foundational, I would say, as some of the models provided by the big tech companies, but at least it is based on a lot of data and also really, I think, for multi-purposes. Another example is, I think, also really to focus on fusing the data-driven algorithms with the physical equation, like physics-informed machine learning. For example, here in this application for Earth orientation parameter modeling, where you can really then see the impacts of sea level rise, deformations of the crust, and processes in the Earth interior. Final example, explainable AI, which is also really important because we want to understand and what the algorithms are doing and less rely on it like a black box. So here, example from GNSS reflectometry, where they really were able to find the feature importances for individual pixels of their measurements. So this called delay Doppler maps on the resulting products like the wind speeds over the oceans. And this really helps to understand what the machine learning algorithms are relying on in terms of their input data. With that, I'm already at the end, and in the interest of time, I think I skipped the summary. Thanks a lot.
For the nice presentation. Are the questions or comments from the online community? Okay. For the clear community, there is one question.
It's a question concerning your slide number 4 about the investments in AI. Is it investment of USA companies or of worldwide companies?
It's worldwide, but
including China?
Yes, although still the US is really by far the leader in terms of investments in AI. So I think more than 50% actually is happening in the United States, but also China is really definitely the second most important. And yeah, they are, in terms of language models, I think they are even producing more. I think they have a lot of models in the pipeline. Like actually, I think 200 large language models will come out in the next years, probably from China. Yes.
And did they show already some numbers about the gain, the revenue, what comes back?
Oh, that's a good question. This is not what's shown here, but yeah, I don't have any statistics on that. But I think in the beginning it will see probably not very much.
It will take some more time.
But yeah, indeed. I mean, if AI replaces, for example, search engines like Google, then yeah, there will be a lot of revenue for sure.